All right, so this is section 4.2b, some selected homework problems I want to go over with you. So let's start with 29. So 29, it says use upper and lower sums to approximate the area of the region using the given number of subintervals of equal width. So I redrew the graph given in the book, and we see that we have five rectangles that we want to use. So let's first start off with upper sum. So upper sum is we're trying to draw rectangles where we want them to be circumscribed rectangles, where portions extend above the curve because we want an over approximation. So in this case, for the five rectangles, we first need to find the width of each rectangle. We know that our left endpoint is 1, our right endpoint is 2, and we want 5 intervals or 5 rectangles. So our width is simply going to be b minus a over n, 2 minus 1 over 5, which is 1/5, which is 0.2. So starting at 1, we keep adding 0.2 until we get to our endpoint, our right endpoint. So 1.2, 1.4, we keep adding 0.2, 1.6, 1.8, and finally 2. Okay. Now, if we draw these rectangles, we see that for each rectangle, if we want an upper sum, we're going to actually using the upper left endpoint of each rectangle to cause our rectangles to be circumscribed. So our upper sum will be using the left endpoint of each rectangle because this curve is always decreasing. So for each rectangle, it'll be consistent. We're always using the upper left endpoint of each rectangle to help us indicate the height of each rectangle. So what that means is we need to find the width of each rectangle. But first we can set up and find the area of each rectangle. Okay, so the area of each rectangle is simply going to be the width times the height. So for my first rectangle was 0.2. 0.2 is my width. My height is going to be using the left endpoint at the left x value and extend this to the graph, so f of 1. F of 1 will give me the height of my first rectangle. F of 1.2 will give me the height of my second rectangle. So let me mark these here, 1, 2, 3, 4, 5. Okay. For my third rectangle, f of 1.4, all right, f of 1.4 will give me the height of my third rectangle. F of 1.6 will give me the height of my fourth rectangle, and f of 1.8 will give me the height of my fifth rectangle. And I'm simply doing width times height for each rectangle. Okay. And then if I want to find f of 1, f of 1.2, f of 1.4, then I can plug them simply into my function, 1 over x. So f of 1, simply 1 over 1. F of 1.2 is simply 1 over 1.2. And 1 over 1.4, so on and so forth. And all these values I can plug in the calculator, add them all up, and I'm going to get a upper sum of 0.746. So this is going to be an over approximation of the actual area under between the curve, the x-axis, and my left and right endpoints. Okay. If I want to find my lower sum, if we want to find the lower sum, then we want to draw the rectangles so that we have portions of the graph, we have gaps below the curve. We want an under approximation, so we don't want any portion of the curve to be above the x-axis, to be above the curve. So we want to be choosing the upper right corner of each rectangle to cause these to be an inscribed approximation or inscribed rectangles. So for my first rectangle, I'm going to be using, instead of using f of 1, now I want to use f of 1.2, because f of 1.2, we want this, will extend to this point, and this point, we want this point to be indicative of our height for my first rectangle. So again, 1, 2, 3, 4, 5. So same thing as before, width times height, width times height, width times height, width times height, width times height. Okay. I'm sorry, this should be f of 2. F of 2. Okay, so my lower sum will simply be, now all these values I found from before except for f of 2, but f of 2 simply will be 1 over 2, which is 1/2, and my lower sum will be 0.646. Right, 63, now we want to use the midpoint rule with n is equal to 4. Our function is x squared plus 3, so I drew the graph here between 0 and 2. So first step, we want to find the width of each rectangle. Our width formula is b minus a over n. So 2 minus 0 divided by 4. So my width is simply 1/2. So starting at my left endpoint, I can figure out the intervals by adding the width until I get to my right endpoint. So 0 plus 1/2 is 1/2, plus 1/2 is 1, plus 1/2 is 1.5, plus 1/2 is 2. Okay. Now, with the midpoint rule, we want to be using the height that is associated with the midpoint of each rectangle, the midpoint x value for each rectangle. So for my first rectangle, my midpoint will be between 0 and 0.5. So what's between 0 and 0.5 is going to be 0.25 or 1/4. So f of 1/4 is going to be the height that we want for the first rectangle. Okay. And what's between 0.5 and 1 is going to be 0.75 or 3/4. So plug 3/4 into the function, and that will give me the height that we want for my second rectangle. For my third rectangle, between 1 and 1.5 will be 1.25 or 5/4. Same thing, plug into the function. And finally, f of 7/4, 2 is 0.75 or 7 over 4. Plug that into the function, and that will give me 1/2. I'm sorry, that will give me 49 over 16 plus 3. So I have all the heights that we want. So now we set up our area formula for each rectangle. So width times height for my first rectangle, width times height for my second rectangle, third, and fourth. And all this we can plug in the calculator, and we're going to get an area of 69 over 8. Okay, 65. Again, midpoint rule. Now our function is tangent of x. So tangent of x, I drew a sketch of it between 0 and pi over 4. To find the width, we do b minus a divided by n. So my width is pi over 16. So starting at 0, we want each interval to be pi over 16. So add pi over 16 from 0 plus pi over 16, we get 2 pi over 16, which is pi over 8, plus pi over 16, 3 pi over 16, which is 3 pi over 16, plus pi over 16 when we get 4 pi over 16, or reduced to be pi over 4. Okay. So what's between 0 and 1/16 is going to be 1/32. So pi over 32 is going to be the x value that we want to extend to the curve to get to our midpoint, okay, to determine the height. What's between 1/16 and 2/16 is going to be 3/32. What's between 2/16 and 3/16 is going to be 5/32. And between 3/16 and 4/16 is going to be 7 over 32. Okay, so we can, or we could just simply use a calculator to find the average between these two fractions, and that will give you the midpoint. Okay. We can plug all these values into the calculator. These are all representative of the heights of each rectangle that we want. And then to find the area, we simply add up the sums of each rectangle's area. So width times height, my width is pi over 16 for each rectangle, and then the midpoint y values will be found by plugging all these values into the calculator, and we're going to get a decimal value of 0.345.